Everywhere you look, the terms AI, machine learning, and LLMs are thrown around interchangeably, as if they mean the exact same thing. ChatGPT and other chatbots represent one specific tool within a much larger ecosystem. They are a visible application of a technology that is much broader than a chat interface. When we fail to separate these terms, we treat software like conscious magic rather than mathematical mechanics. That confusion leads to unrealistic fears about what these systems are actually capable of doing. To understand what is actually happening inside our devices, we have to map out the exact architecture of these technologies, starting from the absolute widest lens. Looking at this diagram, the massive outer ring represents artificial intelligence. In its broadest sense, AI is the goal of making machines behave smartly. Early AI systems achieved this goal without doing any actual learning. They were strictly rule-based, programmed by human engineers to execute rigid if X, then Y commands. A basic smart thermostat or a standard digital calculator are prime examples of this. You feed the system an input, and it gives you a correct output based entirely on predefined logic. It behaves smartly, but no learning is involved. That logic is flawless for rigid math, but it breaks down when confronted with the messy complexity of human behavior, like recognizing a voice or identifying a face in a photo, where there are simply too many variables for a human to explicitly code. To solve that limitation, the technology evolved. Inside the broad AI category is a smaller layer, machine learning. This shifts the burden from programmer to data. Instead of explicit rules, we feed the system raw data to map patterns on its own. Take a spam filter. The old rule-based method required an engineer to manually block exact phrases like win money. With machine learning, we shove the system thousands of varied emails, and it independently recognizes the behavioral footprint of spam. To pull that off, these systems rely on supervised learning. Humans have to label the initial training data, tagging individual examples as spam or not spam, so the machine has an accurate baseline to learn from. With that shift, the core bottleneck of computing changed. Progress was no longer constrained by a programmer's ability to write endless rules, but by the sheer volume of data we could provide to the machine. This brings us to the tightest circle, the large language model. To tackle human language, we need a specialized tool. LLMs are a hyper-focused subset of machine learning, trained purely on massive text datasets to understand the mathematical structure of communication. Despite how fluid they seem, an LLM possesses zero true comprehension of the words it generates. It operates strictly as a probability engine. If you feed the system the phrase, "the sky is," it isn't referencing a real-world understanding of weather. It is simply calculating that, based on billions of ingested sentences, the word blue is statistically the most likely next step in the sequence. What feels like a thoughtful conversation is, under the hood, just high-speed math calculating the highest probability response, one word at a time. When we pull back to look at the completed taxonomy, the structure is clear. AI is the broad goal of intelligence, machine learning is the data-driven method, and large language models are the specialized tools built for text. This hierarchy reveals the mechanics behind chatbots, producing confident but false information, a phenomenon known as hallucinating. Because the LLM is just a pattern-matching tool within the machine learning layer, it is entirely dependent on its training data. If it encounters flawed or contradictory information, it will flawlessly predict a statistically likely but factually incorrect sequence of words. It cannot lie, it can only calculate. Internalizing this nested hierarchy protects us from the hype cycle. When we recognize these platforms as specialized mathematical tools, we stop assigning them human consciousness, and the technology stops feeling like unpredictable magic. This taxonomy is just the foundation. If you want to explore the deeper technical layers of this space, like how neural networks actually process data, or how retrieval-augmented generation keeps these models accurate, subscribe to the Explainer series for the next breakdown.